So today we will discuss about trigonometry or trigonometric ratios. In short, we are saying T ratios. So what is actually T ratios is ratio of sides of a right angle triangle with respect to an acute angle. Means in a right angle triangle you take any one of the acute angles. So in this right angle triangle, X is also an acute angle, Y is also an acute angle. Angle B is 90 degree. So it is possible to write 6 ratios of the sides. That is AB upon AC, BC upon AC, AB upon BC, BC upon AB, different ratios, 6 ratios. Each of that ratios are called trigonometric ratios or T ratios. They are, one is the first one with respect to this acute angle I am taking X. So AB upon BC, the opposite side of X upon AB upon hypotenuse, sorry, AB upon BC not, AB upon AC, the opposite side of the acute angle X divided by the hypotenuse, that is AB upon AC. It is actually saying that sine of X, and we are writing in short as sin X, not sin X, it is sine followed by the acute angle. Similarly, if I am writing the ratio BC upon AC with respect to X, BC means the adjacent side of the angle X divided by hypotenuse. That is actually called the cosine of X. Means here I put a co means complementary angle of sin X. That is cosine of X. In short, we are writing cos X. So cos X is equal to BC upon AC, where BC is the adjacent side of angle X upon the hypotenuse of triangle. Similarly, next I took it is with respect to X, AB upon BC, the ratio AB upon BC. That ratio is called the tangent of the acute angle X, tangent. It is denoted by tan X. In short, the first 3 letters. Everywhere you are using the first 3 letters of the full name, tangent of X. That is AB upon X, AB upon BC. So tangent is opposite side upon adjacent side of that acute angle X. Similarly, cosecant of X. That is actually the complementary of secant of X. That is actually AC upon AB, means the reciprocal of this AC upon AB. That is cosecant of X. We are writing it as cosec. There we are using the first 5 letters, because if you are using only the first 3 letters which we already use here, that is why we are writing cosec. Similarly, its reciprocal AC upon BC. AC upon BC is called the secant of the acute angle X. That is secants, we are writing short, first 3 letters again used. Here actually its complementary is written there. Complementary of secant, that is actually cosecant. Then the finally its reciprocal BC upon AB, that is cotangent of X. Actually complementary of tangent X, that is cotangent of X. We are writing it short as cot X. So once again I tell you, sine of the acute angle is the opposite side of angle X divided by its hypotenuse. Similarly, cos of X is defined as the adjacent side of the angle X divided by hypotenuse. Similarly, tan X is defined as the opposite side of angle X divided by its adjacent side. Then the remaining are its reciprocal. So I am coming from here. Cortex is same as BC upon AB. BC is adjacent side upon opposite side of angle x. Similarly, sec that is AC upon BC, that is hypotenuse upon adjacent side of angle x. And similarly, finally, cosecant x, that is hypotenuse upon opposite side of angle x. So we will learn that procedure. Opposite side, the opposite side of x is AB, at nearest side, that is adjacent side of x is BC. Some are saying it as perpendicular and base, same thing only. Perpendicular opposite side, base the nearest side, and hypotenuse remains the same. No problem. Anyway, you define it. Similarly, the acute angle y, I took it sin y. The opposite of angle y is BC upon AC. Cos y, the adjacent of this angle y upon hypotenuse. Tan y, the opposite side upon adjacent side. Cot y, the adjacent side upon opposite side. Sec y, hypotenuse upon the adjacent side. And finally, cosec y, that is hypotenuse upon opposite side. So these definitions you learn properly, then only you can understand. There are some relations, reciprocal T ratios. You may see that sin x is the reciprocal of cosec x. You see, sin x is the reciprocal of, here AB upon AC is given, here AC upon AB is given. So reciprocal of sin x is cosec x. So we know that if you are multiplying a number with its reciprocal, result always will come 1. So at any stage I can write sin x is equal to 1 upon cosec x, reciprocal. Similarly, cosec x is equal to 1 upon sin x. 1 is the reciprocal of the other. In a similar way, cos x, sec x, you may see that BC upon AC and here AC upon BC. So reciprocal of cos x is sec x. So we may write as sec x as 1 upon cos x. Yeah, cos x is equal to 1 upon sec x. At any stage you can write. Similarly, tan x and cot x. So reciprocal T ratios product always will be 1. Also you may see that tan x is same as sin x upon cos x. Sin x, if you are dividing by cos x, this you are dividing AC cancel, AB upon BC you will get. And similarly cot x is same as cos x upon sin x. So tan is always sin upon cos and cot is always cos upon sin. You may see that here all these trigonometric ratios are defined only with an acute angle. Means if a student is not writing this x, then it is not trigonometric ratio. Trigonometric ratio will be completed only when you are writing an acute angle here. Otherwise they are not trigonometric ratios. Tan is not a trigonometric ratio. Tan is trigonometric ratio only when you are using an acute angle there. Acute angle 0 to 90 degree acute angle there. Now one example I wrote here, if tan theta is 5 by 12, means if one trigonometry, you can write all other trigonometry. You see tan theta I took it as acute angle, its opposite upon adjacent, opposite is 5, adjacent 12. It's actually a ratio. You may use here a ratio, you can write a k here also, not necessary. Even though you may write or not write, that will get cancelled because ratio, that common thing always cancelling. So 5, 12, so by Pythagoras theorem 13 will get the hypotenuse. So you can write sin theta 5 upon 13, sin theta 5 upon 13, opposite upon hypotenuse. Cos theta 12 upon 13, adjacent, base upon hypotenuse. Cot, base upon opposite. Sec theta, hypotenuse upon base, that is sec 13 upon 12, and finally cosec theta 13 upon 5. So I use one of the question here, sin square theta plus cos theta equal to, so square of a trigonometry means a square we are writing actually in the trigonometry, but it is same as that trigonometry square. Plus another cos theta is written, so sin theta is here 5 upon 13, so squared 25 upon 169 plus cos is same as 12 upon 13, adding you will get 181 upon 169. In a similar way, you can find out any trigonometric ratio, square or anything you can calculate with the help of these values. If one trigonometry is given, you can find out all other trigonometry with respect to that acute angle. Now let us see trigonometric tables. Means trigonometric values are, there are some trigonometric values are that is defined, well defined. They are 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Out of the 0 and 90 is presently not in the syllabus, but still I used it here because in coming classes you will have to use it, that 0 and 90, that is why it is written. Now then technically it is written, if you can by heart that is better. By chance you forgot, there is a simple technique applied. This table is already given in your textbook also. Sin 0, sin 30, sin 45, sin 60, sin 90. These values having a particular relation. You take 0, 1, 2, 3, 4 continuously. Take their square root and divide it by 2. You will get 0, 1 by 2, 1 by root 2, root 3 by 2, 1. You can check it. 0, root 0 is 0, 0 upon 2, 0. Root 1 is 1, 1 upon 2, 1 by 2. Root 2 upon 2, that is 1 upon root 2. Similarly, root 3 upon 2, that is written there. Similarly, root 4, that is 2 upon 2, 1. So, sign values, write it in the reverse order. Last one, this reverse order you write, you will get cos values. Reverse, whatever, this way you are written, write in the reverse order. You will get cos values. Then divide sine by cos, as I already told you, tan is same as sine upon cos. 0 upon 1, 0, 1 by 2 upon root 3 by 2, 1 by root 3, 1 by root 2 upon 1 by 2, 1, root 3 by 2 upon 1 by 2, that is root 3, 1 upon 0, not defined. Then take the reciprocal. The reciprocal of tan is equal to cot. Reciprocal of 0 is not defined. 1 by root 3 reciprocal root 3, 1 reciprocal 1, root 3 reciprocal 1 by root 3, not defined. Reciprocal 0. Similarly, reciprocal of cos is sec and reciprocal of sine is cosec. Some important point we keep it in mind, it's very important for assertion reasons. Sine values are increased from 0 to 1. Sine values are always increasing, you may say 0 to 1. As angle is increasing from 0 to 90 degree. Means when angles are increasing, sine values are also increasing. But the cosine values are not like that. As the angles are increasing, cosine values are decreasing. Cosine values are decreasing from 1 to 0. 1 to 0, you may see that 1 to 0. Tan values are also increasing, cot values are decreasing. Tan values are increasing, but cot values are decreasing, reverse order. Then, sec and cosec, secant values and cosecant values are always greater than or equal to 1. Secant value cannot be less than 1 because reciprocal of a number from 0 to 1, sine and cos are 0 to 1 values. Its reciprocal never lies in between them. They will be always lies more than 1, greater than or equal to 1. No one can say sine secant is equal to value, sec theta is equal to 1 by 2, not possible. Sec theta minimum value is 1 or more, minimum value 1. Okay, similarly cosec also. Then there is some important also, you can see this sign, as I told in the starting part, they are called complementary. Sin 30 and cos 60 remain same because 30 and 60 if we are adding you will get 90. You may see that sin 30 and cos 60 remain same. Any values are like that. Sin 0, cos 90 are going to same. Sin 30, cos 60, sin 45, cos 45. Similarly for tan, cot and sec. Tan and cot complementary, sec and cosec complementary. That relation is that. Tan 60, cot 30 because 60 plus 30 is 90. Sec 0, cosec 90 because 90 plus 0 is 90. That is complementary, that is the reason. Complementary means sum of the angles total is 90 degree. like properties are there. So you have to by heart either, or you make it whenever required by using this technique. It is very useful. It is very useful for exam purpose also. Some questions I wrote here. Find the value of these numbers. All values are substituted from their cos 30, sin 60. All these values substituted, simplifying root 3 by 2. Similarly, another question this came in your examinations. Cot raised to 4 means cot 30, whatever the value is there, power it as 4, that is root 3 raised to 4. Cosec raised to 4 means cosec value 2 by root 3 raised to 4. Similarly, 3 by 2 into sec 45 root 2 square, tan 30 1 by root 3 square minus cos 60 1 by 2 square, because squares are written there. By simplifying all this, you will get 55 by 18. Simplification, you check it whether it is coming or not. Another type of question, sin of a plus b and sin of a minus b. Two angles sum and difference are same. So sin of a plus b is root 3 by 2 only when you are writing here 60. Sin 60 is root 3 by 2. That is why a plus b equal to 60. You may see that sin 60 is root 3 by 2. Similarly, cos of a minus b root 3 to cos root 3 by 2 is coming, root 3 by 2 is coming in 30. That is why a minus b here when you are writing 30, then only this 30 will come. So a minus b equal to 30, root 3 by 2 then only will come. Simplifying, adding, we will get a is equal to 45. So put that a here, you will get b is equal to 15. This type of questions are very important. Similarly, another question, if a is equal to 30, verify cos 2a is equal to 1 minus tan a upon here. Tan a upon 1 minus tan square a upon 1 minus tan square upon 1 plus tan square. So I use that a is equal to 30 here. So when I am using in LHS, so 2 into 30, that is 60. Cos 60 is 1 by 2. Simply RHS, when I am using 1 minus tan 30 is 1 by root 3 squaring 1 by 3. Similarly, 1 plus 1 by 3. Simplifying, you will get here also 1 by 2, here also 1 by 2. LHS equal to RHS, hence verified. Another question, tan 3 theta equal to root 3, find theta. Here this 3 theta in the place of 3 theta you are using 60, then only this much you are writing 60, then only you will get root 3. So 3 theta equal to 60, so theta equal to 20 degrees. So such questions always will come in the examination. Now there are some identities that we will discuss now. So there are some questions is written. We will use identities. We will prove it. So first question is 1 plus root of 1 plus cos theta upon 1 minus cos theta. If in the denominator 1 plus or minus sin theta or 1 plus or minus cos theta is coming, always if you are changing the sign, or in short conjugate multiplying, always the result will come. So let's see here. Inside the complete root itself, I change the sign here, conjugate and multiply in the numerator. The advantage is inside the root 1 plus cos theta the whole square. Inside the root the square is coming, then square root will go. Similarly, 1 minus cos theta and 1 plus cos theta is sin square theta. Root I remove. So because squares are there, inside square root the square means both will get cancelled. So remaining is 1 plus cos theta upon sin theta. Separate the LCM, you will get 1 upon sin theta plus cos theta upon sin theta. That is cosec theta plus cot theta. Second question is written like this. Either you can do by the similar way, or here already its conjugate is there. I took the LCM so that directly will get. You may do like this way also, but since one is the conjugate of the other, that is why I took the LCM. Now when I am taking the LCM, this 1 plus sin theta root 2 times is coming, it will go. Similarly, root 2 times will come, square will come, so that root will go. Remaining in the denominator is root of 1 plus sin theta and 1 minus sin theta. So sin theta cancel, numerator will come 2 upon 1 plus sin theta and 1 minus sin theta is cos square theta. That is root again will go 2 upon cos theta, that is 2 sec theta. It's a simple way. Very simple questions are coming in the examination. This is one of the difficult questions usually students are feeling, but not tough. Cos a minus sin a plus 1 upon cos a plus sin a minus 1. This is cosec a plus cot a. You may see that cosec a is 1 upon sin a and cot a is also 1 sin cos a upon sin a. both of this sin A is the denominator, so I divide each and every term by sin A. So I divided cos A upon sin A, that is cot A, sin A upon sin A, that is 1 upon sin A, that is cosec A. Divide in the numerator also, denominator also. Denominator, numerator like this will come. Cos A upon sin A, cot A, plus sin A upon sin A, 1 upon cosec A. So 1 upon sin A, that is cosec A. Then I rearrange cosec A and cot A together. Denominator you cannot there is no advantage, but numerator having advantage. Cosec A plus cot A can be written as 1 upon cosec A minus cot A, as I told you, reciprocality ratio in the previous case. Cosec A plus cot A, if it's there, then reciprocal is that 1 upon cosec A minus cot A minus 1 as like that. Now take the LCM. When I am taking the LCM, 1 minus cosec A plus cot A divided by this will come. You may see that numerator and denominator remain same. This and this get cancelled. 1 upon cosec A minus cot A. So again 1 upon cosec minus cot is cosec plus cot. Reciprocal. Cosec plus cot. Simple identity is used. Then here another questions. You see the result, sin and cos is written the result. So I converted tan also to sin and cos and cot also to sin and cos. So after that I took the LCM. Cos theta is the LCM. So cos square theta will come, because in the denominator will come the numerator. Cos theta minus tan, that is why cos square theta upon cos theta minus sin theta. Plus here also sin theta LCM will go in the numerator. So sin theta minus cos theta. But here a problem is there. Here it's cos theta minus sin theta. Here it is sin theta minus cos theta. See, if I am taking a minus outside, denominator remains the same. So means LCM remains the same. That is why I took cos theta minus sin theta. So here it will come minus, plus will changes to minus. Because I took a minus outside, so this plus will come a minus. So same denominator. So single LCM. Then a plus b into a minus b use. Cos theta minus sin theta cancel. Remaining is cos theta plus sin theta. So lot of questions are there. So you practice and ask me any doubt is there. Then you may just give me message. I will give the result.